Good morning. Hi. My name is Seth. I'm part of Core Services Engineering, which used to be Microsoft IT. So we're the team inside of Microsoft that runs the business of IT. So we deploy solutions, obviously, that we sell, and we try to share that with our customers. So I'm going to talk today about a developer kit that we built inside the company that we've released as an open source solution on GitHub, and talk through sort of the challenges we've faced in adopting Azure and moving to DevOps model within that, and some of the things that we've learned along the way. So this is just a quote, but I think it should be pretty relevant and true, is that the majority of security issues we're seeing is not necessarily product or service based, but configuration and the basics, as you want to think of it. Where we started and where the IT industry started, forever ago, was that there was a central IT governance or security team and a cloud service provider, where there was complete control from the centralized team over what could happen, all the settings that were enforced, and basically a single point or a single gate. However, we found, and as all of our customers will find, that there's a lot of changes that happen when you move services or applications or resources into the public cloud, is that when we first started, there was a lot of sort of grassroots or siloed development happening amongst different app teams, right? Since it's so easy to create and spin up a subscription and start developing, in the public cloud natively, a lot of teams took advantage of that. As a central security team, our groups really looked at, how do we control this but not stop the agility that we're, promised out of working in the public cloud. So we started at this challenge to see what were the main differences. And like I said, security was really a gate or something that was done as part of the development cycle. We modified our processes over time, where it used to be just security review at the end, till we nested security professionals into the DevOps or sprint teams and sort of adjusted that way. But we still couldn't keep pace with the speed of development that was happening in some of these app teams, even by nesting a security professional in the team. We had to figure out, how do we basically build this into the process so that developers are able to create and develop securely throughout the process. Security isn't a point in time anymore. It's very much a continuous thing that has to be verified, validated, even early in the development lifecycle. And that's something that's changed. In the past, when you're developing on-prem applications inside your public network or your private network, you didn't really have to worry about security until you went into production, and that might be customer-facing or internet-facing. When you're developing in Azure, there's a lot of services that are natively cloud-facing and are open to attacks and exploitation before you even have a production application. And a lot of developers are just not used to that, where even if they're using synthetic data or something like that, if they're exposing endpoints to the public internet, there's a big opportunity for reverse engineering that can be used when the application goes into production. So we started with the sort of problem set that I mentioned before, and luckily we had no security incidents of major to report before we implemented this. But what we did was create what I mentioned to begin with, was the Secure DevOps Kit for Azure, and it's been shortened to the AZSK. So if you search for that, and I think there's a link at the end of this too, it'll easily come up. And there's a number of things that it addresses. And it's a combination of PowerShell scripts, Visual Studio Team Services extensions, and Azure automation accounts and scripts. So we started with subscription security. So that's really the baseline. And that's actually a completely new concept in relation to how computing is done, as there wasn't a subscription before public cloud. So the subscription security is implemented across subscriptions by the individual developer teams. And what this aims to do is set some standards, and most of these are defined by our internal security teams as to what was relevant to Microsoft. All of this is generally number one, it's open source. You're able to access the source code, but also you have the ability to customize all of this. So the way it's set up out of the box or as installed, it's going to apply security policies that we deem as, I guess, most important or critical. So in this case, it's Azure Security Center, making sure that that's implemented, looking at role-based access control, and also ARM templates that isn't listed there. But it puts in place, basically, give you a base, they give you a base sort of level of subscription security across your environment. Next is development security. So you've secured the subscription through basic policy and implementing the security settings there. When development is actually happening, we have extensions that add into Visual Studio that optimize the IntelliSense coding algorithms to include common security pitfalls. So things like not setting encryption, where keys are stored, and then security verification tests. So these are also implemented and available. And like I said, all this is configurable, and you don't necessarily have to use every component of it, right? If you're using a different IDE, then maybe this doesn't apply to you. The next one is CI/CD. So this is more applicable to Visual Studio Team Services or Azure DevOps, and it has extensions that do essentially the same thing, but on a continuous manner through the agile process and continuous delivery. So it can add into your build pipeline steps that are required for release. And then continuous assurance runbooks. So these are things that are built on an Azure automation account and automation scripts. And like I said, security is no longer just a point in time or a milestone to hit. It's something that has to be continuously checked and verified in live services. And the beauty of this is you can schedule it, you can modify again what it is that's important to your organization. It has checks for SOX compliance, things like that you might want to tune or add to depending on what your individual security situation is. And the runbooks, one of the key things is to, number one, stop config drift. So once an application or service is in production, you want to ensure that changes aren't made, and if they are, they're identified and shown to the members of the team that are responsible for it, but also to look for additional security possibilities or features that are released where you can have positive config drift, where it's going to suggest improvements based on things that have come out and been released in the Azure portal that might add to the security level of your application. Azure monitoring. So it's going to create standard logging and monitoring dashboards that are applicable to security in that given application or across multiple subscriptions, depending on what your scenario is. And again, this comes down to the fact that you can't ask these DevOps teams to instantly become security experts. So the purpose of us creating that was to sort of spread not knowledge, but the ability to easily identify and fix security vulnerabilities in code as it's being developed, right? And that's a challenge that I don't think we'll ever get past, until every service is perfectly secure, and I don't see that happening in the future. But realistically, as I said, you can't expect all the dev teams to be security experts. You have to give them the tools and processes that make it easy to do security. And then risk governance. So this is really just a way to roll up telemetry across different subscriptions and organizations so you can identify trends. So inside your own environment, what you'll start to see is reporting that shows the most common security vulnerabilities that are missed during a development lifecycle or during production, and allow you to base policy on that. So like I said, it's an open source basically package of different features that you're able to customize yourself based on whatever your security needs are. And it's not going to create 100% security out of the box. A lot of this is really alerting and basically flagging for when security settings are off or when policies are not set correctly in your subscriptions or services. So when we look back inside of Microsoft, we've been migrating and adopting Azure, since its inception. We were one of the first customers to, internal customers to use the service, and these are some of the things that we wish we knew back then and what brought us to today. So we didn't have visibility across all of our accounts, subscriptions, etc. That was something we had to figure out, as we were flying the plane. And I think the tooling has come and improved over time, but part of the purpose of this was to identify any sort of seams between the different aspects of how security is implemented in Azure and apply some simple, scripting and packages to ensure that we actually cover those gaps or those seams. And then this is sort of the vision of the future, is security as a service, and understanding how that gets integrated across not just individual services, but environments as a whole. So here's some best practices just in general to obviously take care of when you're looking at cloud adoption and when your organizations are starting to move. And some of it's common sense, and some of it's things that really weren't an issue or something worth addressing before you were in the public cloud. So with that, any questions? Who's deploying workloads into Azure already? Developers, admins, security folks? Wow, okay. Were you familiar with this? Had you heard of it before? Okay, yes and no. Who's going to check out more? Awesome. Yeah, so as I said, it's AZSK, and we have a great, it's actually, I think it's azsk.azurewebsites.net, and it's got an awesome README file, or README section, that goes through not only every feature that's in here, but how to customize that based on your environment. Because you have the capability not to just use our security settings, but to build your own ARM templates, JSON queries that run based off of standards that you set. Any questions? I'll just hand you the mic, because I'm not sure. You should have a second.
Yeah, how does it actually integrate with the Azure Security Center? Because most of the things which the kit does is even rolling out to Azure Security Center. So what's the development or the future roadmap for this kit?
Tess. The question was, how does it integrate with Azure Security Center? So right now, it's really setting up default alerts in the Azure Security Center so that the end user DevOps teams don't have to, you end up with the same set of Security Center alerts, et cetera, to start with. That's its purpose. As Security Center evolves, and internally, of course, our hope is that it does and includes more and more of these features. I think the need for that component of the kit potentially will go away. I think a lot of the other parts of it will still be valid because some of that, especially the code that's executed on an end user's PC or through Visual Studio or some other IDE, is not going to be part of the portal.
And one thing about the ARM temperature checker, I saw that in the code it actually uses the SVTs, but it's not extensive. Like, it only does very few minimal checks at the moment. So is there any plan to keep developing the ARM temperature checker of the kit?
Yeah, there is. So I think, I'm trying to remember what the next release date was, but it's constantly being developed. There's the ability in GitHub to request features or report bugs. So put in a request based on the functionality that you want. It is fairly basic at the moment, and some of that has to do with how we provide governance internally inside of Microsoft, and the way that we distribute ARM templates inside the company is through a private repo. So we're less reliant on verification of individual ARM templates because they generally come from the same source that was developed by our security policy. Any other?
So how does this work on existing subscriptions, or is this best used on a new subscription?
Sorry, I missed the first part.
Is this best used on a new subscription or an existing?
So is it best on new or existing? So it works for both. So with a new subscription, it's basically, you've actually set up the subscription before you start to install the DevOps kit. So in either situation, it's really not it works the same way. So you're going to apply the scripts, the PowerShell scripts, mostly to an existing subscription, whether it's brand new or it exists already. So it's not part of the subscription setup or anything like that. It runs separately on through PowerShell.
You were talking about a website, right, where it is available? You're talking about a website where all this is available?
Yeah, exactly. And it's azsk.azurewebsites.net. And we just changed that, so sorry it's not on the slide.
So how you would ensure, because if you, for example, hook the DevOps into a subscription, right, eventually dev group can deploy any kind of ARM script. So let's say they are deploying PaaS services. How you will make sure that it stay on PaaS services, that they don't stray and then suddenly start, how you will make sure that they are deploying what they're meant to deploy constantly?
Okay. So how do you ensure that they're not deploying other services? Is that the question?
Exactly. How do they stay in the boundaries of their own project? Or
So some of that comes down to the dev test lab settings. But then the other part of that is more about reporting rather than stopping. So it's not going to implement anything that's going to prevent the deployment of resources of any type in general, but it's about the telemetry that reports up to ideally a central source that's built into the subscriptions that are provisioned. So regardless of the environment that they're in, if this is installed and mandated, and that can be checked through telemetry and cross-referencing your own subscription, basically you'll catch when that happens. But I think it's a combination of monitoring or alerting based on that, and a combination of just applying policy that shouldn't be violated, because at some point it has to come down to the people.
that's true, but for the large production environments, like there's always a scare from the managed service providers that with ARM scripts you have too much freedom, right? So for the production environment, that shouldn't be changed. So if you hook a DevOps pipeline into it, they're always scared of the ARM script. So there is always a question: is there a way to limit in that area, like during the pipeline? But okay, I understand. Thanks for the answer.
So Azure-Management groups are going to start to put some controls around that. I don't know if you followed that development. We're in the process of adopting it internally inside of Microsoft, but it's another layer of policy enforcement that's going to work across multiple subscriptions and provide a better level of control across your environment. So we're looking forward to that as well, because it actually addresses some of the pieces that you can't control just through this kit.
Thanks.
All right. Well, that was it. Thank you very much. I will be right over here if there's more questions, and there's actually a couple more security folks here today at the booth. Thank you for coming.